Hello everyone, welcome to today's presentation. My name is Matt and I'm going to be leading this presentation today. We're going to be talking to you in this brief webinar about importing Revit Geometry into Altair SimSolid, but also to Inspire. If you are joining, having attended my previous webinars, you've likely heard of SimSolid and maybe you haven't heard of Inspire before. I think it's a really good opportunity to look at kind of the synergies between the two tools, how Inspire can help with accessing SimSolid solver, and also doing some pre and post processing of the geometry as well. It's capable of much more, but if you're strictly looking to run a mesh-free simulation in SimSolid, I think Inspire can really be a great avenue to accomplish that. Now, for a bit of an introduction to myself, my name is Matthew. I manage the Global Technical Team's AEC group, and I'm based in Vancouver, Canada. And today I'm going to be talking about how we can export our Revit geometry from Revit into SimSolid or Inspire, like I mentioned earlier, to run a simulation on 3D geometry. We'll then look at how we can review the geometry. We can make changes to it if it doesn't necessarily reflect our intentions with the model. We'll also look at running an analysis, and at the end we'll have time for a Q&A as well. So with these short webinars, you'll notice if you've attended my webinars in the past that these have less slides and they're more just kind of jumping into the presentation. So we hope you enjoy that and we'd love to hear your feedback on how you think that went. So let's go ahead with this. I've got a model in Revit, and this model is of a louver system that is, as you can see, suspended from the side of a structure. And we want to analyze this with the SimSolid solver. Now, I do want to point out here that there are some modeling quirks, if you will, to the geometry that we'll probably better identify once we get into the solver itself and into Inspire. But I really want to focus on the geometry itself, just introducing it. So you can see here we've got some horizontal beams that are supporting these louvers and some rods as well that are connected at an angle to the adjacent structure. And what I'll notice just right away maybe is one of the examples that we pointed out here is that we've got these louvers that basically extend along the entire length of this of the system. Now it's up to us if we want those to be basically cut through the beams or if we want them to be separated by the beams. That's something that we might interpret differently than how the model is currently created, and that's totally fine. We can make those adjustments once we get into Inspire. But I want to actually just select the components I want to export to the step file, which is what I'm going to use to export this geometry. So I'm going to select it all here, and I'm going to go to the File menu, and I'm going to go to Export. And here when I click on Export, there's this option that says CAD Formats. And when I click on this, you can see that there's a couple different formats available to us. Now there's a few different ones that Inspire and SimSolid will accept. So we have STL, we have SAT, we have step file. I personally like the step file as my preference of these options. If you do have an option for Parasolid, I would say I'd actually choose that over the step file. But in the absence of that, a step file should work just fine. So I'm going to click on this option here. And on my other screen, I'm just going to drag this over. It's giving me a preview of basically the geometry that I've selected in the 3D view. And I can configure this export with a few different settings here. So I can say, what units I would like to import or export this with. The schema for the step export, I'm going to just stick with the AP242 for now. But if you have a reason to, you can certainly experiment with the different export settings that are available. Then I'll just click the next button. And it's going to ask me to save this. You'll notice I have a few different sample files here. Let me just call this, I'll just call this live, save, and it's going to choose to save it as a step file. Now click OK. And if I just bring up that folder path here, we'll be able to quickly see that we've got this live save file that's been exported at today's date and time. And it's got a total size of 46 kilobytes. So not very large, but it contains the information that we need to basically move on to the next step. And I should note that we're using Revit for this example. I've personally gone through similar exercises using other tools like Tekla. So Tekla 2025 has a very similar export to step that will take this information and share it with other formats that might not necessarily read in a native step or a native Revit or Tekla file directly, but step is going to be a little bit more universal for 3D simulation. So I'm going to go into Inspire now, And if you haven't seen Inspire before, it is available with your Altair units if you're using SimSolid, or maybe you're using S-Frame and you have a couple licenses of S-Frame. You probably have a number of units that would allow you to use Inspire. And I'm not going to be able to do Inspire justice with its description, but it's basically I would say, a CAD tool that has built-in analysis, built-in optimization. It's great for meshing and mesh-free simulation as well. And it can do everything from fluid dynamics to manufacturing simulations and much, much more. For this particular exercise, though, I'm going to take advantage of some of its modeling capabilities. So I'm going to go to the File menu, and I'm going to click on the Import option. And I'm going to start by clicking on this live save.step option that I just exported. And I'll click Open. And you can see the geometry has come in. And it's come in exactly how it was written in the step file. And that may or may not always be in our best interest, but it's something that Inspire does give us the tools to manipulate this. If we were to import this into SimSolid, we wouldn't have all the editing tools directly, but we can actually run SimSolid Solver through Inspire directly. So here, I've got the geometry, and we'll be able to quickly identify some of the quirks related to this that I showed earlier. For example, these louvers here, they basically extend through the entire set of these horizontals. I've also got some, I would say, oddities related to some of these different brackets. So here I've got this circle with another circle inside of it. And we can actually combine these all together using the different tools to represent the type of geometry that we want to actually analyze. So here, if I click on this Boolean tool, for example, in the geometry ribbon, I can go here and I can say, okay, I want to combine these different objects together. For example, I want to combine this and this. Click apply. I'll just do that maybe just one time for now. I'm not going to worry about repeating it. I can say once I'm done, I accept that change. And now basically we have combined those two parts into one part for that hung support. And maybe for our louvers here, we're going to split those up. So I'll use the Boolean command again, but this time I'm going to use the subtract option. And I'm going to select all the targets. So basically I want these longitudinal louvers to represent the targets. And for the tools, I want to cut these. So I'm going to basically say all of these horizontal cantilevers are going to be my tools. And I just basically left click on the parts that I want to represent those tools. And you can see that we have some also additional conditions that we can control here. So I can keep those tools if I want to, or I can delete them. I can also remove the imprints within my tools if I wanted to do that. I'm going to check both of those on, and I'll just click Apply. Right-click to end the command, and you can see here now it's been broken up, but it's still keeping those as kind of one part along the entire longitudinal. But I can control that as well just by right-clicking and saying, let's just convert these bodies to different parts. And now each one of these individual segments is its own part in the CAD file. A few other details that we can look into are related to, well, the same commands. I can go to the Boolean subtract, and I can say, you know what? This particular rod extends into this hung support. So why don't I select my target as this rod? And I'll do the same thing for all the others as well. And we can actually select along a line or a larger kind of selection set here. And for my tools, I want those to be basically everything else that I'm working with here. And what this will allow us to do is basically just cut off the extension or the penetration of our specific rods into these parts. So I'll click on the play button here to apply. And then if I go through and just rotate my view, we can see that we had this little extension that went through. I'm going to convert this to parts as well. And I can just get rid of those extensions as I need to. Maybe a side view would probably be the easiest way to get through that, and we'll be able to continue on with our work. So as you can see, there are little adjustments to the model that we can make if they don't automatically represent our intentions. Perhaps whoever built this CAD model didn't necessarily have the intention that they were going to eventually have this running in a simulation software like Inspire or SimSolid. Once we get it the way we want, we can then switch to the structure window or structure tab here. And I can set up things like my contacts, my loads, my supports. So I could go in here and apply my supports to the parts that I want to apply those supports to, apply my loads, and then run SimSolid Solver directly from Inspire. Now, if you're loading up SimSolid or Inspire, for the first time, you may not necessarily have the SimSolid Solver as your default, but you can go to the File menu, and then under the Preferences button here, you can actually change that. So you can go to Run Options under Inspire, and you can see that right now I have the Analysis Solver set to SimSolid. I can switch it to OptiStruct if I would like to take advantage of the more optimization-focused solver as well, rather than SimSolid, which is the mesh-free solver. Now, for the sake of this exercise, I've actually accomplished or gone through and adjusted a few more parts of the model that would have just been a little bit more tedious if I had to do that in front of you guys here. So I'm just going to quickly switch to SimSolid's interface. And you can see here that I've got the SimSolid interface directly rather than from embedded within Inspire. And I'm going to click on the Import from File button. And I've got this adjusted two-step file that basically is just a continuation of the model that I was just showing you. So it's got all those modifications made to it. You can see that when I import this, it's come up with its automatic connections tool that I'm going to come back to later. But just to maybe explain this a little bit more, if I go to, let me just display my parts in different colors, we can see here that each one of these louvers has been broken up, like I mentioned earlier. I've also got the hung supports. Those are modeled as unique objects, just like I saw before. And one of the quirks of my CAD model, my Revit model, was that these rods, they were actually not extending all the way to this surface here. If I just quickly show you, zoom in a little bit, you can see that they're basically cut off. So there's a slight penetration, but it's not going all the way into that part. So I actually extended these and then sliced them to represent what I considered the more realistic condition that we would experience in the real world. So with all that done, I can now use the automatic connections within SimSolid, and I can say, okay, well, go to the Connections workbench, and I'll use this automatic connections tool that allows me to specify gap and penetration tolerances. Again, if we did have some imperfections in our CAD, we could always use a larger tolerance for the gap, for example, to represent the fact that those parts weren't quite connected, but we want them to be. That's totally up to us if we decide to. I'm going to click the OK button now, and you can see really quickly it flashed on screen to show me that it had generated some connections, but I can actually view those here. If I click on this, right click, and go to Show All, and I can see all these different red colorings representing the bonded connections between the louvers and the horizontal cantilevers, as well as the base plates and the hung supports that we see up there. Now I can also set up my analysis. So I could say structural linear, perhaps. And I can go in and I can say, oh, I want to define an immovable support. And I can click on the faces or the edges or wherever I want this to represent. I can click on those parts to represent the immovable support, which is basically preventing it from moving or rotating at that face. And like I've mentioned before in some of my other SimSolid demos, if we have a lot of support locations, that will probably be the most time-consuming part of this whole process. I'm going to click Apply, and I'll just turn on the display of my boundary conditions, and we can see those yellow parts are now showing up, indicating that face has been applied a movable support. Continuing on here, I can go in and I can say, well, with this, I want to apply some loads, so we could go with a pressure load or maybe a force. I'm going to go with the force here and just assume that we have, perhaps on an edge of this surface, maybe we've got somebody standing on the edge of this. And you'll really be testing my unit conversion skills here, but I'm just going to say that we've got a few different spots where somebody's standing just on this one particular edge. And I'm going to give it a force in the Z direction of, let's say, 1,000 newtons, just to give it a nice number. Now I can display that if I wanted to and see what those are appearing as, so we can see what it looks like on our screen. And I could go ahead and solve this as well. I can click Solve. I forgot to apply my material. Luckily for me, the default material is steel. I often forget to do that in my demos, but in this case, I'm going to assume this is all steel. And now we can see SimSolid is running the analysis. I'm going to go ahead and look at how long that took to run. the total runtime of 11 seconds as it appears there. And I can start looking at my results. I'm just going to turn off the display of my supports and boundary conditions. And let me look at my displacement. So I'll look at displacement magnitudes, and I can see what sort of displacement magnitude we're getting for this particular system. I can actually render this, and it's going to show me the displacement throughout the model in an exaggerated form. I can also point out the maximum and minimum displacements at any one location. So you can see the displacement is quite low in this example, obviously based off of the input loads that I defined. I can also look at my stresses, so I can see how much stress I'm getting in different parts of the model. And again, it's quite low. So perhaps the loads I've applied didn't really stress this to any significant limit. But if they were getting close to some sort of threshold, we could also set up like a safety factor where we can consider, okay, anything within this tensile yield stress range with a safety factor that defined as a high and low threshold, we can display that. Now in this scenario, I'm well below my safety thresholds anyway, so it's not going to really factor in. But we could certainly look at how this might display if we had a higher stress structure. So that's a very quick kind of walkthrough of SimSolid and Inspire, getting our model prepped for an analysis in SimSolid if it didn't necessarily already meet our expectations. The beauty of this setup is that they all draw from the same pool of units, so you're not necessarily having to purchase a separate tool to do that pre-processing that we have in Inspire. And if you really wanted to, you could run the entire simulation within Inspire without having to switch to the dedicated SimSolid interface. So hopefully this gives you a bit better understanding of how this process works. Obviously, we have plenty of other presentations on SimSolid. If you'd like to learn more about the tool, you're more than welcome to check those out. They're on our YouTube channel at Altair How To. I did want to open up the floor for questions. I think there might have been a couple asked during the presentation as well, so I'm just going to quickly check those out. So I might just mute my line for a second while I read these questions.